When we step onto a plane, most of us trust that the engines propelling us through the sky are flawless. But what if the very heart of flight, the jet engine, harbored a flaw that engineers have been warning about for years? Today, we're diving deep into a story of innovation, warnings ignored, and the razor-thin margin between safety and catastrophe. Before we take off, make sure you hit that subscribe button and turn on notifications. This story is one you won't want to miss. The story begins in the late 2000s, when a series of near misses in commercial aviation caught the attention of a few engineers working on some of the most advanced jet engines in the world. These weren't minor issues. These were subtle, almost invisible stresses forming deep inside the metal components of the engine. The engineers noticed something troubling. In lab tests, certain parts of the engine, specifically the high-pressure turbine blades, were showing signs of microscopic fatigue far earlier than expected. Fatigue cracks in these blades could grow silently without warning until they reached a critical point. And at cruising altitude, a failure wasn't just inconvenient, it could be catastrophic. For years, these warnings circulated quietly within engineering reports, confidential memos, and safety audits. Some called it a ticking time bomb. But the engines had passed standard safety tests. Regulators had certified them. Airlines ordered them by the hundreds. And in the relentless drive for efficiency, lighter, faster, more fuel efficient, these tiny flaws were largely dismissed as manageable risks. One engineer who requested anonymity described it like this: "We were shouting into a storm. Everyone wanted the innovation, the speed, the market advantage. Nobody wanted to hear about the cracks." What made this flaw particularly dangerous was that it wasn't obvious. Unlike a mechanical failure you could spot during routine maintenance, this was invisible to standard inspections. It developed inside the engine at temperatures exceeding 1,000 degrees Celsius, in an environment no human could ever survive. The metal would slowly weaken, layer by layer, until a sudden, violent failure occurred. In aviation, history has taught us that invisible flaws are among the deadliest. From metal fatigue in early jet airliners to hidden design defects in older propeller planes, engineers have always known that the devil is in the details. And sometimes, the details are deadly. By 2015, the whispers grew louder. Internal reports flagged recurring issues in the same engine model, now installed in hundreds of aircraft worldwide. Maintenance teams noticed unusual vibration patterns during flight tests, but initial investigations attributed them to minor calibration errors. The engineers who first raised concerns knew the truth. If the problem wasn't addressed, it was only a matter of time before a catastrophic failure occurred. And then came the incidents that could no longer be ignored. Planes experienced in-flight engine shutdowns, sometimes mid-Atlantic or over remote regions. Investigators scrambled for answers, trying to reconcile the performance records with the physical condition of the engines. Each investigation pointed back to the same issue: the high-pressure turbine blades. The microscopic cracks were growing faster than anyone had predicted, accelerated by the very efficiency improvements that had made the engines so desirable in the first place. The manufacturers faced a dilemma. Admitting the flaw meant grounding hundreds of planes, billions in losses, and a public relations nightmare. Ignoring it risked human lives and a tragedy that could shake the aviation industry to its core. At the heart of this story is a tension that is all too human: the clash between progress and caution. Engineers, bound by duty and expertise, had foreseen the danger. Executives, bound by profit and competition, hesitated. And passengers, blissfully unaware, continued to fly, trusting that every component had been tested to the highest standard. Experts outside the company began to weigh in. Aerospace analysts, professors of materials science, and veteran pilots all emphasized the criticality of the issue. But bureaucracy, certification procedures, and economic pressures slowed the response. Each month, each flight, the invisible cracks in the engine blades were growing. And while the public remained unaware, a silent countdown was unfolding inside hundreds of jet engines across the globe. This brings us to the moment where the quiet warnings start colliding with reality. leading to urgent recalls, tense investigations, and debates over aviation safety that would make headlines worldwide. When the problem could no longer be ignored, aviation authorities stepped in. Airlines were forced to ground affected aircraft, some in the middle of peak travel seasons. Billions of dollars in revenue hung in the balance. But more importantly, the integrity of the entire industry was under scrutiny. Investigators and engineers pored over thousands of flight hours, maintenance logs, and metallurgical reports. They confirmed the fear that had haunted the initial warnings. The high-pressure turbine blades were failing under conditions that had once been considered safe. The efficiency improvements, ultralight materials, higher operating temperatures, and tighter tolerances had pushed the engines beyond what the design could safely handle. The recall and repair process was painstaking. Every affected engine had to be removed, disassembled, and each blade examined. In many cases, manufacturers introduced redesigned blades made from new alloys, capable of withstanding higher stress and resisting crack formation. It was an engineering feat born from a lesson painfully learned. Speed, efficiency, and profit cannot outweigh safety. But the story doesn't end with replacement parts. The incident sparked a broader conversation across the aviation world about how safety is prioritized, how warnings from engineers are treated, and how much risk is acceptable in the pursuit of progress. Aerospace regulators implemented stricter guidelines for testing engines under extreme conditions, requiring more exhaustive stress tests and longer inspection cycles. Airlines were forced to rethink maintenance schedules, and engineers worldwide began scrutinizing even the smallest anomalies in engine performance data. For many engineers involved in the early warnings, there was relief but also frustration. Relief that their concerns were finally validated. Frustration that it had taken near catastrophe for the world to listen. One veteran engineer put it simply, "We weren't trying to make headlines, we just wanted to keep people safe." The incident also had an unexpected side effect. It changed the culture within engine manufacturing companies. A new emphasis on transparency, whistleblower protections, and open communication between engineers and management became standard. Internal reports that might once have been shelved or ignored were now carefully reviewed and acted upon. Lessons were learned not only about material science, but about corporate responsibility and the human cost of ignoring warnings. Interestingly, this flaw also sparked innovation. New testing technologies emerged. Advanced imaging techniques, real-time vibration monitoring, and predictive algorithms capable of detecting microscopic fatigue before it became critical. What was once invisible could now be tracked, and aircraft maintenance became more proactive than reactive. The story of this jet engine design flaw is a reminder of how small, invisible issues can escalate into crises if ignored. It highlights the delicate balance between innovation and caution, and how crucial the voices of experienced engineers are in guiding that balance. It also serves as a powerful lesson for all industries. Progress without safety is dangerous. Cutting corners for efficiency or speed may yield short-term gains, but long-term consequences can be devastating, not only financially, but in human lives. Aviation, perhaps more than any other industry, cannot afford to gamble with invisible risks. As airlines return these planes to service with redesigned engines, passengers may never know the invisible battle that took place inside those turbines, or the engineers who fought tirelessly to prevent disaster. Yet the outcome is clear. Vigilance, expertise, and the courage to speak up can make the difference between catastrophe and safety. The next time you board a plane, think about the countless hours of human ingenuity, analysis, and care that keep every flight smooth and safe. Every turbine, every blade, every tiny detail matters. And behind every successful flight are the voices of engineers who refuse to be ignored. This story is a reminder that the most critical discoveries often come from the people who see what others refuse to see. In aviation, as in life, progress is only as strong as the warnings we choose to heed. If you found this story eye-opening, Don't forget to like, share, and subscribe for more in-depth stories that uncover the hidden truths shaping our world. And remember, sometimes the smallest details make the biggest difference.